I can rewrite expressions with positive exponents. So rewrite the fractions using only positive exponents for variables. Simplify numerical terms. So that means if you end up with a 4 to the third, you don't leave it as 4 to the third. You simplify it into 64. Okay, that's what numerical terms means. Only positive exponents. All right, so let's take a look at this one. We have 4 to the negative third. That's the same as 1 over 4 to the positive third. And now here we have 7 to the negative second power on the bottom of a fraction. I can turn that into a positive exponent by bringing it up to the top of the fraction. It becomes 7 squared. Okay, let's think about why that is for a second. This 1 over 7 to the negative second power is the same as 1 divided by 1 over 7 to the second power. Well, 1 divided by a fraction is the same as 1 times the reciprocal of that fraction. So instead of doing all of this, basically if you have a negative exponent in the denominator of a fraction, you could make it a positive exponent by bringing it up. You have a negative exponent in the top, you bring it down to make the negative exponent positive. So here I can just simplify. This is 49. And this is 64. And we leave it. Okay? All right. Now here, we have a fraction bar. This is just division. So 15 divided by 5, that's 3. Now I have x to the negative 2 power and x to the first power. So remember, we subtract when we divide. So we have negative 2, and if there's no exponent here, there's understood to be a 1. So I have negative 2 minus 1. So I have x to the negative 3. And here I have y and y to the negative 2. So I have 1 minus a negative 2, which is y to the third. Okay, I just have left this blank under here. There's basically just a 1. So now I'm pretty close, but I still have a negative exponent. So the 3 is fine, the y to the third is fine. But this x to the negative 3 needs to become x to the positive 3 down on the bottom of the fraction. And that's simplified. Okay. Now here, this is the power of a product, rule. So this is going to be 4 squared, which is 16. X to the 5th squared, we multiply these, x to the 10th. Okay, if you didn't remember that rule, think about what this actually is saying. This is 4x to the 5th squared. So it's 4x to the 5th times 4x to the 5th, which is 4 times 4, which is 16. X to the 5th times x to the 5th is x to the 10th. Okay, both ways you get the same answer. Okay. All right. I know this is hard to read. This isn't very clear on the screen, so I'm gonna rewrite this problem. We have 5a to the 4th, b to the 3rd, times 12a to the negative 2 times b. Okay, so we have, this is just multiplication. 5 times 12 is 60. A to the 4th times a to the negative 2. Okay, here, this is the product rule. 4 plus a negative 2 is a squared. 3 plus, if there's no exponent, there's a 1 there. 3 plus 1 is b to the 4th. Okay, that's the first one. Now this one here, we have 8x to the 9th divided by 2x to the 3rd. 8 divided by 2 is 4. X to the 9th divided by x to the 3rd. Quotient rule says we subtract. So this is x to the 6th. Now here, let's follow our PEMDAS. This is the opposite of 2 to the 4th. So we have 2 times 2 times 2 times 2, and then at the end we're going to attach the negative. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is negative 16. This is different. This is negative 2 times negative 2 times negative 2 times negative 2. And the difference is where the parentheses are and the negative. When it's outside the parentheses, it's not attached to the number. This is the opposite of 2 to the 4th. This is the quantity of negative 2 to the 4th power. So here we have a negative times a negative is a positive, times a negative is a negative, times a negative is a positive. There's an even number. So we're going to have a positive answer, positive 16. Okay. All right.